Hello everyone, I am Nitin Kirti, working as assistant professor in Department of Civil Engineering at Vignam Bharati Institute of Technology, Hyderabad. My MTech specialization is Highway Technology from VTU, Belagaum, Karnataka, and have 3 years of experience in teaching. Hoping you all are doing good and safe at your home. So this is my new YouTube channel. I am going to upload some videos related to the BTech courses for the JNTU students. The fourth year, second year semesters have a subject called as Pavement Design. It is an elective subject. So this is my first video on Pavement Design course. Coming to the outline of this video, so I'm going to discuss about first requirements of pavements, and which includes the subtopics structural requirement and functional requirement. Second, pavement types and their choices, and it includes some subtopics, types of pavement, stresses in pavements, and choice of pavements. Third, I'm also going to discuss the design factors for flexible pavement and in detail about the design factors for flexible pavements in the next video. So coming to the next slide, so what are the structural requirements and why we need to consider in a pavement? So a pavement is nothing but any structure which is laid so that the road vehicles can move freely. So the total thickness of the pavement and the thickness of the individual pavement layers should be sufficient to withstand the heavy traffic loads and the repetition of wheel loads of different magnitudes. So as I said, so the pavement is usually used by road vehicles, and the pavement should meet all the requirements. It may be a structural requirement or a functional requirement, so that the vehicles will move at a design speed with a good riding comfort. So coming to the structural requirements, we have to consider some of the requirements such as traffic loads, load repetition, climatic variables, and environmental factors. So why we need to consider these requirements? Because the stresses induced on the pavement are within the permissible limits under the existing climatic and environmental conditions. So whatever the traffic loads coming on the pavement and whatever the load repetitions of different magnitudes, they produce some stresses, and whatever the stresses induced should be some permissible limits under whatever the climatic conditions we can say or environmental condition we can say. So when I talk about the climatic conditions, the climatic condition could be the variation in the rainfall and temperature, and the environmental factors like height of the embankment, depth of the water table. So why the depth of the water table is important in case of environmental factors is nothing but, so the depth of the water table can also affect the structural capacity of the pavements. So we will study in detail, or I will discuss the flexible pavement, the cross section of a flexible pavement, and the rigid pavement, the cross section of a rigid pavement in detail in the subsequent slides. So next, coming to the functional requirements. So these are the 3 requirements has to be satisfied. First, riding comfort. Second, economic operation, and safe operation. So the pavement should provide good riding quality for the vehicles moving at design speed throughout its service life. For example, if you take a flexible pavement, the design life is 15 to 20 years. So it should provide a good riding quality or riding comfort throughout its design life. If I take a rigid pavement, it should also provide the good riding quality or riding comfort throughout its design life. For example, the rigid pavement is having a design life of 30 years. So next, economic operation. The second functional requirement, economic operation. The unevenness or undulation cause some vertical oscillations of the vehicles, resulting in poor riding quality. So whatever the undulations occurs, because of poor riding quality. So what this undulation leads to? The undulation increases the vehicle operation cost. So indirectly it increases the economic operations of the vehicle. Also, if the pavement surface is very slippery, then it results in skidding of the vehicles and results in unsafe operations. That is the last functional requirement, that is safe operations. So therefore, I can say the functional requirements of the pavement is to provide safe, comfortable and fast movement of vehicles and goods at a reasonable low vehicle operation cost. Coming to the next slide, pavement types. So mainly we come across three types of pavement: flexible pavement, first, second, rigid or cement concrete pavement, and third, semi-rigid or composite pavement. So what is an flexible pavement? So in the next slide we are going to see a cross section of a flexible pavement. So this cross section you can see, so the lowermost layer we can say it as a subgrade. So the lowermost layer is a subgrade. So below subgrade we are going to provide an embankment. So why we need to provide an embankment? Whenever the pavement has to be constructed or raised above the ground level, or the existing ground level, embankment has to be constructed. Why embankment has to be constructed is, this is very essential to keep the subgrade, whatever the subgrade provided above the embankment, the subgrade should be above the water table, or you can say a higher water table in the ground, to prevent the damage of the pavement due to surface water and capillary water. What happens if below somewhere here there is an higher water table? Okay, so if you provide a if you provide the subgrade directly without any embankment, so what happens, whatever the water present in this water table, if I will just write here w wt, so water table, so wt, so this wt, what happens, the water table, if it is very nearer to the subgrade, so the water may percolate into the subgrade and it may disturb the optimum moisture content and maximum dry density of the subgrade. So to prevent the damage of the pavement due to surface water and capillary water, and to maintain the design standards of the highway with respect to vertical alignment, or with respect design standards with respect to the subgrade, CBR value of subgrade, so we have to rise an embankment above the existing ground level. And after the subgrade is the subbase, which mainly consists of wet mix macadam. It's a granular layer, and later on base course, that is wet mix macadam. Subbase is a granular layer which also acts as a drainage layer, and after that base course, which is an layer, we call it as wet mix macadam, and this we can call it as GSB, granular subbase. So these are the component layers we may come across, and at the top we are going to provide a black topping which may consist of these layers, normally BM, that is bituminous macadam, comma, another is BC, bituminous concrete, or dense bituminous macadam and bituminous concrete, BC. Or in low volume roads or village roads, they are just going to provide the SDBC, semi-dense bituminous macadam, above the base. So clear about the cross section of flexible pavement. And next, coming to the typical cross section of the rigid pavement. So here in rigid pavement, what happens? So if required, if the higher water table is there, so if required, they will provide an embankment here. They will provide an embankment if required, or else they may not provide an embankment. So here directly in this typical cross section of rigid pavement, there is a subgrade which is an existing soil. Above that, sub-base course which is a granular layer. If needed, they will provide in a rigid pavement or they may not provide. And above the sub-base course, there is a base course, or we can say it as a DLC. DLC, dry lean concrete, can also be provided, and above that a concrete slab. And in the concrete side we have to provide the transverse joint and a longitudinal joint. So this is a typical cross section of rigid pavement. And the flexible pavement, rigid pavement, what's the difference between these two? So the flexible pavement, I can list out some points, like it consists of series of layers with the highest quality material at or near the surface, and it reflects the deformation of subgrade and subsequent layers on the surface. Third point, its stability depends on aggregate interlock particle friction and cohesion. Fourth point, pavement design is greatly influenced by the subgrade strength. Fifth point, it functions by the way of load distribution through the component layers. And the design for flexible pavement is as per IRC 37. And coming to the rigid pavement, some of the points I am going to just list out. First point, it consists of one coarse Portland concrete slab of relatively high bending resistance. Second point, it is able to bridge over localized failures and areas of inadequate support. Third, its structural capacity is supplied by the pavement slab itself by beam action. Fourth, flexural strength of concrete is major factor for design. Fifth, it distributes the load or the V load over a wider area of subgrade because of its rigidity and high modulus of elasticity. And design of rigid pavement will be carried out as per IRC 58. Next, coming to the whatever the stress distribution we can see through the granular layers. So as I mentioned, what are the granular layers in the flexible pavement and rigid pavement? The granular layers are above the subgrade, sub-base course, granular sub-base course, and above the sub-base course, base course, that is wet mix macadam. So here in figure 1 you can see some pressure distribution through typical granular materials. On figure 1, the A subsection, you can see some large boulders were used before. So in the large boulders you can see the V load is acting only on the one of the boulder, and in the B subsection figure you can see large size aggregates. So the boulder is being reduced to the sizes of large size aggregates or stones. So 3 large size stones are there, but whenever the V load acts on these large size stones, it will just get distributed to these large size stones only. Okay. And in the C, you can see the subsection figure C, you can see these large size stones is again reduced to smaller size, that we say it as stone aggregates or road aggregates. So whenever we lay these stone aggregates or road aggregates in layers, so whatever the V load or the load coming from the road vehicles will be distributed in the form of a truncated cone, as you can see. So this is a truncated cone. So the wheel distribution takes place in the form of a truncated cone in the case of flexible pavements. Next, coming to stresses in flexible pavement. So as I said, so whatever the loads are there, it will be distributed in the form of the V load coming from the road vehicles will be distributed in the form of a truncated cone. And again the same, whatever the cross section I have described in the previous slide, so that is been shown again here. Fill or embankment, and second fill or embankment, and second is the prepared subgrade, and after that is the granular subbase, or it also acts as a drainage layer, and after that granular base course, that is wet mix macadam, and after that binder course, and after that bituminous surfacing. Okay. So next, coming to factors affecting the dispersion of compressive stresses. So whatever the stresses induced by the road vehicles, we say it as a compressive stresses. So these are the factors are just listed out here. Characteristics of material in each pavement layer is important. Second, thickness of each layer is important, and also the load characteristics is important. And coming to the another figure of a typical cross section of cement concrete pavement or rigid pavement. So here you can see again a fill or embankment, and after that a drainage layer, or you can say a base base course, and after that lean concrete cement concrete or sub base, and lean concrete sub base, and after that cement concrete slab. Okay, so in the previous slides I've shown you the typical cross section of a rigid pavement. So if required, you can provide a fill or an embankment below, and or whatever the subgrade will be there, that also sometimes considered as a fill there, and above that granular base course will be considered, and above that sub base course will be considered, and after that cement concrete slab. So the last type of pavement, that is semi-rigid pavements. So it is the combination of a flexible pavement and rigid pavement. So I'm just going to list out some of the points here. So the points, like the first point, intermediate class of materials used in base or sub base course. And second point, the intermediate materials. What are those intermediate materials? It may be bonded material like lime, fly ash, aggregate mix, or soil cement mix, or a soil cement mix. Third point, they have slightly higher flexural strength than flexible pavements. So these semi-rigid pavements, if I talk about, flexible pavements are having very low flexural strength, rigid pavements are having very high flexural strength, whereas semi-rigid pavements are having a slightly high flexural strength. Means between flexible pavement and rigid pavement. Next. Fourth point, they do not possess as much flexural strength as cement concrete pavements. As I mentioned, semi-rigid pavements lies between flexible pavement and rigid pavement. And last point, the materials used in semi-rigid pavements have low resistance to impact and abrasion. So as fourth year students, you have already studied you already studied the transportation engineering laboratory in fourth year first semester. So there you have studied some of the test on road aggregates. So in test on road aggregates, the first test is aggregate impact value test, and next aggregate crushing value test, Los Angeles abrasion test. So whenever we conduct the tests on the stone aggregates or road aggregates, they will be having some resistance value. So whatever the stone aggregates or road aggregates used in semi-rigid pavements will be having a low resistance to impact and abrasion. So choice of pavement type. So till now we have seen the pavement types: flexible pavement, rigid pavement, and semi-rigid pavement. So based on these factors listed here, you can select the type of pavement. So the first factor is initial cost. So initial cost is very important. For flexible pavement, the initial cost is, you can say, very high. For rigid pavement, the initial cost is very low. And second, maintenance cost. The maintenance cost for flexible pavement is very less, whereas the maintenance cost for rigid pavement is very high. Third, total transportation cost. So the total transportation cost, again, if you go for the flexible pavement, as I said, the initial cost will be high. So obviously whatever the total transportation cost will also be high, whereas for rigid pavement the initial cost will be less, so the total transportation cost will also be less. And the availability of funds, depending upon the availability of funds and depending upon the traffic volume, we are going to choose the type of payment to be provided in that vicinity or in that area. So coming to the design factors for flexible pavements, so here I am just going to list out the design factors, and in the next video I am going to explain the design factors for flexible pavement. So the design factors listed out here are the various factors to be considered for the design of flexible pavement are as follows. First, design wheel load. I can denote it as capital P. Subgrade support. Second, third, material in pavement component layers. Fourth, climatic and environmental factors. And fifth, drainage characteristics. Hope I have cleared some of the topics explained you. If you have any doubts or any clarification, you can comment in the comment box. Thank you. Have a good day.